Hello dear students, today we are going to discuss a topic from plus 1 physics, which is units and measurement. And after discussing the basics of this topic, units and measurements, not all the content but a small content of unit and measurement, after that we will discuss 2 or 3 questions from the previous Neet question papers. Okay, so first of all we will go through the main content of first section of this chapter, units and measurement. First important topic is physical quantities. What is mean by a physical quantity? That is the first thing that you must know before entering into this chapter. A physical quantity is nothing but which is a quantity that can be measured directly or indirectly. So there are different types of quantities you can measure it, either by directly or by indirectly. All such quantities are together known as a physical quantity. Okay, so you can say as an example length, which you can measure, a mass you can measure. So all these things are an examples for a physical quantity. Okay. Now the physical quantities are mainly classified into two. One is fundamental quantities. First category is fundamental quantities. The name itself says what is the importance of this quantity. They are the basic or fundamental quantities. That means they cannot be expressed in terms of other fundamental quantity. So suppose there is a fundamental quantity like length. This cannot be expressed with any other fundamental quantities. So such type of quantities are referred as fundamental quantities. That means those quantities which cannot be expressed in terms of any other quantities is referred as a fundamental quantity. There are 7 fundamental quantities. First one, length. Length is an example for fundamental quantity. Second one, mass. Third one, time. Fourth one, temperature. Fifth one, electric current. Sixth one, luminous intensity. And the seventh one, amount of substance. These are the 7 fundamental quantities, and all these quantities cannot be expressed in terms of any other physical quantities. That is why it is referred as a fundamental quantity. Okay. Now the second type of physical quantity or second classification of physical quantity is derived quantities. Derived quantities. Here you can simply say that the definition of fundamental quantity that we have already mentioned, that means these quantities cannot be expressed in terms of any other quantities. So derived quantity is just inverse of this. That means a derived quantity which is a physical quantity that can be expressed in terms of another physical fundamental quantities. That means any quantity that can be expressed in terms of physical fundamental quantities is referred as a derived quantity. That means you can express these derived quantities in terms of other physical fundamental quantities. Like we can give some example, speed. Speed is nothing but distance by time. Distance is having the condition of length. So the speed is expressed in terms of 2 fundamental quantities. One is distance and other is time. Distance is nothing but length. Okay. Similarly, you can say the term force, which is mass into acceleration. This acceleration is not a fundamental quantity. This acceleration is nothing but velocity by time, change in velocity by time. Again, velocity is not a fundamental quantity. Velocity can be written as displacement by time. Okay, so look at this. here displacement, which is a fundamental quantity, which is nothing but which is having the dimension of length. So distance, displacement, both are having the dimension of length, so they can be considered as a fundamental quantity. Thus displacement by time, which is referred as velocity, that velocity by time is referred as acceleration, and then mass into acceleration is equivalent to force. So a force can be represented in terms of a fundamental different fundamental quantities. So that is why force, speed, velocity, acceleration, momentum, all these physical quantities are examples for derived quantities. That means except the 7 fundamental quantities, that is these 7 fundamental quantities, all other physical quantities are belonging to the category derived quantities. All other physical quantities are belonging to the category derived quantities. Okay, so these are the main 2 types of physical quantities: fundamental quantities and derived quantities. Okay, now we are moving into the next term, units. The term units, it's a very important term. While we are mentioning a physical quantity, we are providing some magnitude to give some measurement for that, but the only magnitude only does not do the work, because when we are measuring a distance between 2 places, suppose there are 2 places and they are separated by 10 kilometers, you should specify the magnitude 10 along with its unit kilometers, otherwise there is no significance for that. If you are just mentioning that the distance between 2 places is 10, then the observer or then those who are reading this will ask whether it is in kilometers or in meters or in centimeters or in miles or any other units. So you have to provide the exact or proper unit while you are mentioning a physical quantity. So what is meant by a unit? Unit is which is a basic amount or standard amount of the same quantity as reference. Okay, so in order to specify a physical quantity, you need to give some standard reference of that physical quantity. So that is referred as unit. Okay, so you must keep in mind that the importance of unit, because you are just specifying a number that won't work. You have to give in what unit you are expressing that physical quantity. Okay, now based upon the same thing, the fundamental quantities, we are having 7 fundamental units. Before entering into this 7 fundamental units, you need to have different system of units that followed in different countries. At least the basic names of the units systems. One is CGS. C is a unit that is representing centimeter for length, G is gram for mass, S is second for time. Centimeter, gram, second, which is a unit normally used in France. Okay, and another type of unit is FPS, foot, pound, second itself. Foot is the unit of length, pound is unit of mass, S second is unit of time, which is normally used in Britain. Then third one is MKS system of unit, where M is meter, K is kilogram, S is second. Meter for length, kilogram for mass, and second for time. In all these 3 units, second is common, but look at the unit of length. In one it is centimeter, then a foot, then meter. In the case of mass, gram, pound, and kilogram. So these are different units used in different countries. So while you are considering internationally, you have to use some unit that will be accepted internationally. So there is 7 fundamental units and 2 supplementary units are provided internationally. They are referred as SI system of units, SI units, system internationally, SI units. For length, the SI unit is meter m. Meter m is representing for SI unit of length. For mass, it is kilogram. For time, it is second. For temperature, it is Kelvin. Capital K is used to represent the SI unit of temperature, which is Kelvin. For current, it is ampere. For luminous intensity, it is candela. CD is used to represent the unit candela. And for amount of substance, mole. Mole is used to represent the amount of substance. So M for meter, then kg for kilogram, S for second, capital K for Kelvin, A for ampere, CD for candela, MOL, mole for mole, which is amount of substance. In addition to these 7 fundamental units, there are 2 supplementary units. So these 7 are belonging to the category fundamental units. In addition to these 2, there are 2 supplementary units. They are radian for plane angle. For plane angle, we can use the unit of radian, normally indicated by the letter RAT. And steradian for solid angle. For solid angle, there are the unit steradian, SR is used. So these are the basic units of SI system, 7 fundamental units and 2 supplementary units. Meter for length, kilogram for mass, second for time, Kelvin for temperature, ampere for electric current, mole for amount of substance, candela for luminous intensity. In addition to these 2, there are these 7, there are 2 other units referred as supplementary units. They are plane angle, which is radian, for solid angle, steradian. Okay. So these are the basic units of physical quantities. Now you can use this fundamental or 7 unit system to express the units of any other derived quantities. Okay. Now the practical units for measuring large distance. So when you are considering a distance between 2 planets or between 2 stars or between from our Earth to Sun, it is not easy to measure it with the units of meter or kilometer. So in such cases, in order to express this large amount of or large unit of distance, we are using some other practical units. First and foremost important unit is light year, LY. Light year. Year is there, but that does not mean that which is a unit of time. Light year means it is the distance travelled by the light through vacuum in 1 year. It is the distance travelled by light through vacuum in 1 year. So you know the speed of light in vacuum, which is 3 into 10 raised to 8 meter per second. 3 into 10 raised to 8 meter per second. That means in 1 second light will travel 3 into 10 raised to 8 meters. So after that, in order to find what is the distance, what is the value of 1 light year, it means that the light travels in 1 year. So 3 into 10 raised to 8 meter in 1 second. So 3 into 10 raised to 8 into 60 means it is the distance travelled by light in 1 minute. If you are multiplying with 1 more 60, it is the distance travelled by light in 1 hour. Into 24 means it is the distance travelled by light in 1 day. Into 365 means it is the distance travelled by light in 1 year. This is the value of 1 light year, which is approximately 9.6 into 10 raised to 15 meter, 9.46 into 10 raised to 15 meters. Okay. Now, second unit for measuring large distances, you can use the term AU, which is known as astronomical unit. Astronomical unit, which is nothing but it is the mean distance between Earth and Sun. Astronomical unit is nothing but it is the mean distance between Earth and Sun. One astronomical unit is 1.496 into 10 raised to 11 meters. 1.496 into 10 raised to 11 meters. Now, third largest unit for distance is, which is not the third largest unit, which is the largest unit of distance, not is practically using, which is referred as parsecond. Which is referred as parsecond. 1 parsecond is 3.26 light years. 1 parsecond is 3.26 light years. So, which is the largest unit of distance? Parsecond. Even the term second is there, that does not mean that this is a unit of time. Here, parsecond means parallactic second, which is the unit of distance, which is the largest practical unit of distance. So, look at this in the descending order of the value of distance. Parsecond, which is the biggest unit or largest unit of distance, then which is greater than light year, which is greater than astronomical unit, which is the order of the unit, biggest unit. Parsecond is the largest unit, practical unit of distance. Light year is the second one, and third one is astronomical unit. So, these are the basic unit systems. Now, third topic is indirect method for measuring large distance. In order to measure a very large distance, you have to use some other methods. Not only this simple, we cannot measure the very large distance directly, or you cannot use a scale or whatever maybe. You cannot use that such devices to measure a very large distance. So, in such cases, you are using the method of parallax. Parallax method is used to measure large distance. Suppose moon is here, and we want to measure the distance of moon from Earth. You are considering two different points on Earth. Suppose these are separated by a finite value d. You know the distance between 2 points on Earth, which is A and B. And we want to find the average distance between Earth and Moon. Here it is the Moon. So, we want to find the average distance between Earth and Moon. So, for that, we are considering two straight lines, which is starting from the Earth to the Moon, and this distance that you have to calculate, let it be r, which provide the average distance between the Earth and Moon. It's not exactly, but it is average distance between Earth and Moon. Okay. Now, look at this. This is like a triangle. Suppose theta 1, which is the angle made by the telescope from when we are observing a moon from position A, that telescope is making an angle theta 1 with the horizontal of Earth. Then when you are moving to another point B, then you have to rotate the telescope for a different angle, which is theta 2 with respect to the ground. So, from the property of triangle, we can find the angle over here, which is theta. The angle made at the moon while you are looking the points A and B from the moon, that you can find. This angle is referred as parallactic angle. This angle is referred as parallactic angle. That is, when you are observing two different points from a position, then you have to shift your eyes. The angle shifted by your eyes is equivalent to a parallactic angle. Look at this. According to the property of triangle, theta 1 plus theta 2 plus theta, that is total interior angle of the triangle, is 180 degree. From this you can find the value of theta, that is the angle, parallactic angle, which is made at the moon, which is 180 minus theta 1 plus theta 2. The value of theta 1 and theta 2 is which that you can find, or which is a non-quantity, because this is the angle made by the telescope while you are observing moon from position A and at position B. Okay, so the value of theta 1 and theta 2 can be easily found. Now you know the property angle is equal to arc by radius. Here we are considering a triangle which is taking the star, which is taking moon, as per our example, is taking moon as the center, and the distance r, that is the distance to point A, is as the radius. You can draw a circle, and angle is equal to arc by radius. Then the value of radius will give the mean distance between moon and our earth, average distance between moon and earth. Radius is equal to arc by angle. Here arc length is equivalent to d, because AB is taken as the arc length, which is the distance between 2 points which in our earth, and angle, which is the parallactic angle, that you can find from this equation. When you use this equation, you can find the distance r, which is the through which this method you can find the distance between the very far objects from our earth. Okay, so in order to find very distance between far objects, you can use this method of parallax to find the distance between the planets or the stars. This is an indirect method, you cannot measure it directly. Okay, so these are the basic things regarding angles. Now we can discuss some previous problems that is frequently asked for Neet examination. The question is that what is the unit of thermal conductivity? So we have just mentioned what are different units and what are the things, but we are not mentioned any other units that you can go through your book. You can find different units of common systems. So from this you can just find this question, the previous question, which was asked in 2019 I think so, not sure about the year, but still you can use this. This is a previous question, but what is the unit of thermal conductivity? Okay, so thermal conductivity, what is meant by thermal conductivity? That means it is the capacity of material to transfer heat through it. So it is the ability of material to transfer heat through it, which is simply referred as thermal conductivity. Suppose sigma is the thermal conductivity of the system, which is given by an equation. Sigma is equal to Qx by A into delta T into small letter t. Qx by A into delta T into small letter t, which is the equation for thermal conductivity. Now you have to specify what are these terms. Sigma is nothing but thermal conductivity. Sigma is thermal conductivity. Okay, Q is heat supplied to the system, amount of heat flow, which is given by Q. X is thickness of the slab, thickness of the material, slab or material. A is area of cross section. A is area of cross section. Small letter t is time. Delta T is change in temperature. So you know this units of all these quantities. Heat is nothing but it is a form of energy. Heat is nothing but its form of energy. Unit of energy is not down, which is joules. SI unit of energy is joules. Okay. Now thickness. Thickness is nothing but length of that material, so whose unit is meter. SI unit is meter. Area of cross section A. Area is nothing but who is having the dimension length into breadth or meter square. Area is nothing but having the unit meter square. Delta T, change in temperature. What is the SI unit of temperature that we have mentioned, which is a fundamental quantity, which is Kelvin. Kelvin is the SI unit of temperature. So delta T is having the unit K, Kelvin. Time, nothing but second. SI unit of time is second. So when you use these units like this, instead of Q, I am just putting its unit joule. Instead of X, putting its unit meter. Instead of area, putting its unit meter square. Instead of delta T, its units K. Instead of small letter t, its unit S. Now look at this, a meter on the top denominator and a meter on denominator. You can cancel this. So the remaining term is joule per meter Kelvin second. So there is no such unit in this example. Joule per meter per Kelvin is there, but not S inverse. Then look at this term, joule per second. That is energy by time. Energy is nothing but work by time. Work by time is nothing but power, whose unit is watts. So instead of joule per second, you can put W, watts. Instead of joule per second, you can put the unit watts. So unit of thermal conductivity is watt per meter Kelvin, or W meter inverse Kelvin inverse. W meter inverse Kelvin inverse. So this one is the correct answer. Which one? Option A is the correct answer. Now moving to the next question. The damping force on an oscillator is directly proportional to velocity. So a thing is given, force is directly proportional to velocity. The unit of the constant of proportionality R. So here, if there is a proportionality symbol, then you have to make it equal by multiplying with a constant. So just you can write F is equal to some constant C into velocity V. From this, what is the expression for C, which is equal to F by V, force by velocity. Force by velocity is the constant of proportionality. Now force is nothing but mass into acceleration. Now look at this, mass into acceleration means velocity by time. Just mass into velocity means displacement by time. So displacement by time all divided by time is there. So mass into displacement by time square. Okay. Now write the unit corresponding to it. Unit of mass is kilogram. Unit of displacement is meter. Unit of time is second. So kilogram meter by second square, because time whole square is there, second square is there. So kilogram meter second raised to minus 2 is the unit of force. It is simply represented as Newton. Later you will see this, instead of kilogram meter per second square, you can also write Newton N. So here correct answer is kilogram meter per second square. Option B is the correct answer. Now to the third question. The unit of permittivity of free space. Permittivity of free space is given by the letter epsilon 0. Okay. You will see this equation in the +2 section in Coulomb's law. There is an equation like this. F is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. F is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. Here F is nothing but which is the force acting between two charges. Here q1 and q2 are the two charges which is separated by a distance r. So from this equation you can write epsilon 0 is equal to, that means take epsilon 0 to the left and F to the right. So the term in the denominator moves to the opposite side of equal, then it will become in the numerator. So 1 by 4 pi F on the numerator of the left, when it is moving into the right hand side, it is at the denominator, 1 by 4 pi F q1 q2 by r square. Now write down the units. q1 and q2 both are charges whose unit is coulomb. R is the separation between two charges whose unit is meter. Force, F is force whose unit is Newton, or you can write kilogram meter per second square, that we have just mentioned in the previous question. So while you are writing these units, instead of 4 pi is just a number, there is no unit for this. So instead of q1 and q2 their units coulomb into coulomb, so you can just write coulomb square by unit of force just Newton, unit of distance meter, so r square is there, so meter square will be there. So c square n raised to minus 1 m raised to minus 2, or coulomb square by Newton meter square is the correct answer. Look at this option C, coulomb square by Newton meter square is the correct answer. Okay, so this is the introduction of the chapter units and measurements. Here we have discussed what is meant by a physical quantity, then what are the two types of physical quantity, that is two classifications, that is fundamental quantities and derived quantities. Thus basic 7 quantities, the 7 quantities that we have mentioned. After this we have just moved to the term units, the 7 units of fundamental systems and 2 supplementary units that mentioned. After this we have discussed the terms largest unit of measurements of distance, that is light year, parsecond and astronomical units, which is the largest one, and all these things that we have mentioned. After that the indirect method to find the distance between the far away objects, that is like between two stars. Then we have gone through 3 previous year questions. Okay, hope this class will be helpful for you. Thank you all.